Hello everyone, welcome to today's workshop. In today's workshop, we are going to make an Arduino visitor counter. So this will help us in maintaining the number of people who go in and out of a venue or a shop and maintain a maximum limit on the number of people inside it, and hence help to maintain social distancing and reduce the transmission of COVID-19. So let's get started. So as you can see in the poster here, there are a number of people waiting outside the shop, and at the door there's a device, and that is the device we are going to make. It's a visitor counter, and it counts the number of people going in or out of the shop or the venue, and that's exactly what we're going to make today. So before that, I want to talk about the assembly first. The assembly is a smart lab based out of In5 since December 2014. Since then, we have done over 250 free workshops, and we have three types of workshops that we do here: hack, code, and data science. So hack is all about embedded systems, IoT, and hardware. For example, today's workshop is a hack workshop. Then there's code, so that includes software projects such as APIs, frameworks, and apps. And there's also data science, which is related to AI and machine learning. So our target audience includes students, professionals, entrepreneurs, and to be honest, anybody who is interested in learning technology and tinkering with it. So yeah. We focus on smart technology and its practical applications, and you can visit our forum on members.theassembly.ae. We are very active on our social media channels on Facebook, Twitter, Instagram, and YouTube. So you can follow us there and stay updated with our workshops and activities. So let's get into the workshop now. Here are a list of the components I've used today. So the first one is an Arduino UNO. The second is an ultrasonic sensor, then an OLED display, a buzzer, jumper wires, and breadboard. So you can easily find these components on Amazon or Noon, and even on other shopping portals. So yeah, and they're pretty affordable as well. And here is the wiring diagram. So you can use the jumper wires to connect the components together. And yeah. So the uses of the visitor counter, there are two. One is for social distancing, to maintain a distance between people and make sure that there's not too much crowd. The second is crowd management, because even without COVID, it's not healthy to have too many people inside a premises. So yeah, crowd management is another use. In the future, you could also integrate this circuit with fans or tube lights and other such electronic equipment inside the shop or office. And by doing so, you can automate the device and save electricity as well. So yeah, let's go. So let's get into the code and let's start coding. So according to the circuit, we have two ultrasound sensors, one buzzer and one display. So let's start with the ultrasound and buzzer for now, and then add the display later on. So for that, I have initialized a file. And here there's a void setup function and a void loop function. Starting off, we have to define which pins are attached to which components. So let's start with the buzzer. Buzzer pin is the 6th one. And the echo pin, for the first ultrasound, so ultrasounds have two pins, one is the trigger and one is the echo. So for the first ultrasound, we have trigger pin attached to 8 and echo pin attached to 9. And similarly for the second one we have 10 and 11. Now we go into the setup and we explicitly tell which pin is for the output and which pin is for the input. So pin mode, we have defined 5 pins. So trig pin 1 is output, echo pin 1 is input, and similarly for the second one the trig is output and echo is input. So basically how the ultrasound sensor works is it sends a trigger or it sends an ultrasound wave and it waits for the wave to be reflected back, and when it's reflected back it's taken in by the echo. So that's how it works, and that's why the trig is output and echo is input. The last one is the buzzer pin. The buzzer pin will be output because we are sending a signal from the Arduino to the buzzer for the buzzer to ring. So the ultrasound sensor basically will measure the distance between itself and any possible obstacle. So at first we want to place the sensors and then find the initial distance between it and any other, maybe the other side of the door or something like that. So for that we calculate the initial distance, and that comes into the setup function. And in the loop function, which is constantly called again and again, in that we will keep measuring the distance to any possible other obstacle that comes. So let's do that. Also serial.begin will be run. So initial distance from the first sensor and similarly initial distance for the second one will be here. Measure distance is a function that I have defined, and I will define it soon over here. So let's take these two and copy them right here. So here it will be the distance and not the initial distance. Yeah. So let's go ahead and define the measure distance function. It will take in a trigger pin number and an echo pin number. Oops. Okay. So basically we make the trigger pin on high and then we let it do that for 10 microseconds and make it low again. And when it's reflected and it comes back, it is taken in through the echo pin. So let me just start. Digital write, trig pin high. So this makes the trig pin as high. Delay microseconds 10, and again make the trigger pin low. And then we take in the echo input. So, so usually when we take in the echo input, we get a duration. So this is pulse in, echo pin high. So when we put echo pin on high and get the input from there, we get a duration. The way we get it is that the the ultrasound wave is first passed, and then when it's reflected back, the amount of time that it takes to reflect back is recorded as duration. And from the duration, we can get the distance. So the duration is divided by 2 and then divided by 29.1 to get the distance. And then the distance is returned, and that's how we get the initial distance and the other distance. So yeah, that's about the ultrasound. Now the next thing is, how will we know if a person is entering or exiting the premises? The way we do it, and that's why we use 2 ultrasound sensors. If the first ultrasound sensor is triggered first and then the second one is triggered, that means a person is going in and the counter is incremented. Whereas if a person is exiting, then the second one is triggered and then the first one. So yeah, that's how we know whether a person is entering or exiting. In the code, the way we do it is by using a sequence. So a sequence is just a string, an empty string. If the first one is triggered, then the sequence becomes 1. If the second one is triggered, the sequence is concatenated and becomes 1, 2. So if the sequence is 1, 2, a person is entering. If the sequence is 2, 1, then a person is leaving. So yeah, so we write this in the loop function. So I've just copied the code and I'm just going to explain it to you. If the distance is less than the initial distance minus 30, then the sequence is concatenated with 1. Also, the sequence at the first character should not be 1 initially. So what that means is we cannot have something called 1, 1. It can only be it can only start with 1 and end with 2, or start with 2 and end with 1. And similarly, if the distance of the second sensor is less than the initial distance of it, minus 30, and that sequence does not have 2 already in the sequence, then it is concatenated with 2. So if the sequence equals 1, 2, then the number of current people are incremented and the sequence becomes empty again, and there's a delay of 550 microseconds. And else, if the sequence equals 2, 1 and the current people is greater than 0, then the counter is decremented. That is, if there are already 0 people inside the premises, then you can't really decrement it. So that's why the second condition is there. And the same thing, the current people are decremented and the sequence is made empty and it is delayed by 550 microseconds for the next loop to start. And if the sequence is 1, 1 or 2, 2, or if the timeout counter is greater than 200, if the second sensor has not been triggered but the first sensor has been triggered and 200 counter has been, the counter has been, it has been a really long time since the second one has not been triggered after the first one, then also it is reset, and if the sequence's length is greater than 2. So all of these are invalid or timeout conditions, and if any of them are true, then the sequence is made empty again. The last thing is that if the sequence is only 1, if the length of the sequence is only 1, then the timeout counter is incremented, else it becomes 0. So this condition helps this one, because this one, when it becomes 200, then only the sequence becomes invalid. So those are the conditions for processing the data for the triggers of the ultrasounds. So we've done the part where the number of people are calculated, and now we have to check whether the number of people is greater than the maximum allowed. So that's what we'll do now. If the number of people is higher, then we trigger the buzzer, and that's how people will know that the limit has been crossed. So if current people is greater than max people, then tone buzzer pin 1 500, and else no tone. So the tone and no tone are functions for the buzzer itself. We pass in the buzzer pin number, and this is the frequency of the sound, and this is the duration of the sound. So so if the number of people have been exceeded, then the buzzer will sound. Another thing we have to do is, in the loop, make a delay of 200 microseconds. This will actually help because every time the loop function is done, there will be a delay of 200 microseconds, so that the device is not overusing itself. So that's why we write that. And the last thing we need to do for this part is to declare some integers. So here we have predefined the maximum number of people as 5, and we can write anything. So the ultrasound is done, and the buzzer part is also done. All we need to do now is to trigger the display as well, because we need to know how many people are there currently, and that will really help us to know. So for that, we're using an OLED display, and we need 3 libraries. So we include them here. So it's Adafruit SSD1306, Wire.h, and Adafruit GFX. So before doing it, we need to include it here. Manage libraries. And here, when you search for the library, so this one has been installed. But if you haven't installed it yet, you'll get something. You'll get a button here using which you can install it. And similarly for this one as well. This one you don't need to install. So after installing it, you need to define the size of the screen. It's a small screen. It has 128 width and 64 height. So after that, we need to initialize the screen. So SSD 1306 display, we pass in the screen width, the screen height, the address of the wire. So this address is usually known already by the display, and -1 is another argument. After that, we define a function just like this one to display the text onto the display. So void display text. We pass in a string, and here we have a couple of lines. So yeah, first you have to clear the display because if you don't do that, it will just display what has already been there from before. Then set the text size to 3 and set the text color to white. Set the cursor to 0, 0. These are just default functions, and then display the text that is passed in, and then display.display will finally display the text. So this function we will call it several times, and we use the function because we want to reuse the code instead of writing it again and again. Then in the setup, we begin the display.begin SSD 1306 underscore switch. So 0x3c is the address of the display. And then we call the display text function, which we defined right here, and we pass in a string. So the setup function will be called first, and it is called only once. So the visitor counter text will be displayed once, and then in the loop function we will display the number of people in the shop. So here we display the current people, and we have to typecast it to string because current people is actually an integer, and here we actually need a string, so that's why we want to typecast it to a string. So yeah, that's about it. We're done with the code, and let's run it. Let's connect it to the Arduino, and let's see how it works. You have to make sure in the tools the board is selected as Arduino UNO if you are using Arduino UNO, and the port is whenever you connect, it's neither of these, but whenever you connect the Arduino, you'll have a third one, and in brackets it says Arduino UNO, so that's the one that you have to connect to. So that's done. So we have some errors to correct before we upload the code. So the first error is this one. The sequence is a string, it's not an int. The second one is here. The initial distance 1, I've declared it twice, but this has to be initial distance 2. Let's try to compile it. Okay, and there's a spelling mistake here. So yeah, it has been compiled and the errors have been resolved. So now we can connect our code to the Arduino and upload it. Okay, so let's start with the connections now. Let's start off with the buzzer. The buzzer is the red wire is connected to 6 and the other black wire is connected to ground. Let's put the 2 ultrasound sensors right here. So the trigger pin of the first one goes to 8. The echo pin of the first one goes to 9. The trigger pin of the second one goes to 10. And the trigger pin, the echo pin of the second one goes to 11. Now let's connect the ground and VCC of the ultrasound sensors. So from here we take the ground and we put it here in the line which says minus, and connect the 5 volt to the line that says plus. Then connect the ground of the first one to ground of the line. Same with the second one. Connect the VCC now to the plus line. And also of the second one. Now take the display. Connect the ground here with the ground here. Connect the VCC here with the plus line. Connect the SCL with A5 here. And connect SDA connect the SDA to A4. And yeah, that's about it. So as you can see, a person moved inside and the counter incremented. So 2 people entered and the third person has entered. 4th person has entered. And now the number of people has exceeded 5, and so the buzzer has started buzzing. Let's see what happens when a person exits. So you saw that as soon as a person exited, the counter has been decremented and the buzzer has stopped ringing. So yeah, that's all about how this works, and hope you can try this out and have fun. Thank you for watching today's workshop. If you liked this workshop, do consider subscribing to us on YouTube and following us on Instagram, Twitter and Facebook. Also, stay connected and watch out for the upcoming workshops. Thank you.